Hello everyone, I am Senthil Kumar PK. This presentation is on Course 2 assignment on the Managing Machine Learning projects. This is part of the wider A product management specialization in Coursera. The topic that I choose today is optimizing the water usage in large farms using artificial intelligence and machine language. As part of the evaluation criteria, this project has to be evaluated on various factors such as opportunity evaluation, crisp DM business understanding, validation plan, machine learning system design, and the potential risks in production. Here is the business opportunity. Agriculture, as you know, is one of the oldest profession in the world. Agriculture is still an labor intensive and water intensive process. Typically, a farmer will ensure that all plants receive the same amount of water on a consistent basis or a fixed schedule. But in reality, depending on the temperature and moisture levels of the plant, some plants might require more water than others. So a fixed amount of water for each plant means either we are wasting water or we are not giving enough water to the plant that is really need of water. Only an agriculturist or an experienced farmer can look at the plant leaves and determine the plant health, determine or measure the soil moisture, and can determine what is the amount of water required for the plant. But doing this manually on a wider scale is really time consuming. So the AI ML opportunity here is we can analyze the photos of the plant health depending on how the plant leaves droop down or whether the plants are dry, also taking into consideration the temperature, soil moisture to anticipate the quantity of water needed for each plant. And then the system can trigger the drip irrigation scenarios, sensors accordingly. We are not going to cover the triggering the sensor part of this project. The solution will result in reduction of water wastage and the irrigation labor that is being used in the farming process. The problem statement, our target user is going to be a farmer or a supervisor of a large farm. Okay, we have already explained the problem and why it matters. In the current state, we are seeing that the farming is still a manual process, and we don't have enough predictive mechanisms to understand how much water a plant needs. So the success criteria would be to optimizing the water supply for each plant at the farm and reducing the manual labor to decide the optimal water supply. The output, some of the output metrics can be varied based on the size of the farm, but I am looking at error rate in analyzing the optimal water need should be less than 1%. Okay, and the water need has to be evaluated within 2 minutes of temperature and moisture readings and availability of the plant image. As part of the domain expertise, we need somebody who would have extensive knowledge on plants, how much water is required for each stage of the plant growth, knowledge of effects of temperature and soil moisture on the plant health. We would be collecting the following data and defining the features. It would be plant types, labeled image of plant types, height of the plant, ambient temperature, soil moisture, season, and weather prediction. Since this is a new topic and it was least explored, obtaining clean historical data will be a challenge. The solution approach would be that we will use the label data to train the image recognition machine classification model to check whether the plants are healthy or in need of water. The data scientist, whom we will employ as part of the project, will decide on whether to use a random forest classification or neural networks, or if there is any other better model that are available. Okay, this classification data will be fed into a system that calculates the amount of water based on the plant height and other factors such as temperature, soil moisture, season, and daily forecast. We will validate the solution with users multiple times. In the first iteration, we would use a mock-up of the solution and obtain feedback from sponsors to validate the business understanding. On the second iteration, we will use a small set of historical data and use a markup model to validate the data understanding. In the third iteration, we will take a small set of the real data and use a heuristic model to determine the data understanding and data processing. We will leverage the feedback and learnings to fine tune the data and understanding the data process. The fourth iteration would be cleansing the real data, setting aside 80% of the real data for training, and developing a simple machine learning model to validate the data on the machine learning model. In the further iterations, we will be fine tuning the model, and we will also use users from the forms to do alpha testing and beta testing. Here are the key decisions in the machine language design. For the deployment, I chose cloud over edge because we see that we don't need a real-time feedback and the processing requirement is high. And we are also assuming that the internet connectivity is good enough. Then, from the learning perspective, we would prefer offline learning because data has to be pre-processed. Then, real-time learning is not required. And for predictions, we are using offline prediction. We need to because we need to monitor the data drifts, and we need to observe the outcome on a recurring schedule. The production risk and drifts. Okay, we can anticipate training skew because the lighting and the quality of the images we vary across different forms and seasons. So the classification system may fail if the system was not trained on a specific image quality. And we would also encounter certain data drift. For example, we would be encountering sometimes drastic daily weather changes such as tornadoes, hails, fires due to extreme weather. These cannot be factored into the data.